This video goes over lesson 3 in your notes. It's over complex numbers. Basically, complex numbers exist when you have a square root of a negative number. So we're talking about I being defined as the square root of -1 and I squared equaling -1. Those are the two pieces of information you really need to know about imaginary numbers. Okay, so if we're looking at example 1, basically all that this changes is if you have a negative under the radical, you're going to have an I in your answer. So the square root of -81, instead of just being 9, is going to be 9i. Kind of to break that down, -81 is the square root of -1 times the square root of 81. This is I times 9, which is where we get that 9i. So from here on out, this is what you're going to do. You're going to look at your -24, or whatever your radicand is. You're asking yourself what perfect square goes into that number. So 4, in this case, on example B. And since it's negative, I'm going to put my negative sign with the perfect square. So I'm -4 times 6. Square root of -4 is 2i. 6 is stuck in, so this would be your final answer. 38 is not divisible by any perfect square, so all we can do is pull that I out, whereas 38 gets stuck in. And on D, -9, square root of -9 is 3i, so we have 2 times 3i, which is going to make our answer 6i. And there's a couple different things you're expected to be able to do with complex numbers, so you need to be able to add them. And basically you're just adding like terms. So on example 2a, we can see that we have a couple things that have i's and a couple things that don't. Add the things that don't have i's and add the things that do have i's, and that's our final answer. We have no more like terms, we can't combine them, that's it. Whereas on C, on B, notice that we have a -1 here that we have to first distribute before combining like terms. So we have -2 minus 5i minus 3 minus 2i. Now, add your like terms. And we always put our non-I term first. So -2 plus -3 is -5, and -5 plus -2 is -7. And that would be our final answer since there is nothing else we can do to combine like terms. That's it for adding and subtracting. With multiplying, you're going to multiply it just like you normally would with this variable. Just one little catch. So 2i times 3 is 6i. 2i times -i would be -2i squared. Well, I squared, if you remember from the previous page, is -1. And so this would be +2. We always write the I part first, so I'm just going to flip that around. So I'm going to do this a little differently from here on out when I see that I. I'm going to do C. That squared means we're multiplying it by itself. So I'm going to write that out, and then I'm going to distribute that 4. So I have 16 plus 4i plus 4i plus I squared. So the first thing I notice is I have that I squared with a coefficient of 1. I know I squared equals -1. So when I see that I squared, I'm going to get rid of it, and I'm going to change the sign. So I have 16 and -1, and then I have 4i and +4i. So my final answer would be 15 plus 8i. Dividing is pretty similar. If you just have a single term, a monomial in the denominator, it's pretty similar to rationalizing the denominator with a radical down there. So this 5i, I know that I need to do something to get that I out of there. What I'm going to do is I'm going to multiply on top and bottom by I. So across the top, 3 times I is 3i, and across the bottom, 5i times I is 5i squared. I see that I squared, and I get rid of it, and I change the sign. So my final answer here would be -3/5i. On question B, when you have a binomial in your denominator, you want to multiply by the conjugate, which means that you're multiplying by the same thing, but we're changing the middle sign. We have to do that on top and bottom, so we're not changing the value of our problem. So we're going to distribute on both parts. We have 2 times 3, 2 times I, 3 times 3, 3 times I, -I times 3, and -I times I. See that I squared, I get rid of it, I change the sign. And so I have 6 plus 2i over 10 And then I noticed that all three of those things are divisible by 2. So I'm actually going to reduce each one of these by 2. And that's my final answer.